Open your phone or sit in a meeting today, and you will be hit with a wall of terminology. Generative AI, deep learning, predictive algorithms. We usually try to sort these terms into neat, separate boxes, searching for one clean label for every tool. But the line between standard software and artificial intelligence has blurred, making these isolated categories ineffective. Treating AI like a museum exhibit with perfect labels creates a dangerous blind spot. It leads us to treat the machine as a magical oracle that knows everything, or to brush it off entirely, missing out on what it actually does well. To actually understand AI, we have to look past the surface labels and analyze its architecture. This requires peeling the technology apart into 4 distinct overlapping layers: capability, functionality, training, and application. Viewed together, this stack provides a reliable map. It strips away marketing hype, revealing what a system can and cannot do. The outermost layer of that stack is capability. This sets the absolute boundaries of what a system is built to achieve. You hear a lot about general AI, systems that can reason across multiple subjects like a human, or super AI, which would exceed our own intellect. These are fascinating concepts, but right now they are entirely theoretical. We haven't built them. The reality is that every functional AI system we use today is narrow AI. They are engineered to perform specific, limited tasks. A chess computer can beat a grandmaster, but it cannot decide to bake a cake. Underneath capability sits functionality, how the system actually behaves. The simplest version is a reactive machine, which processes an input and responds with zero memory of past events. But modern systems operate as limited memory AI, meaning they pull from stored data and recent history to adapt their decisions. When you combine narrow capability with limited memory, the software can feel incredibly perceptive. However, it still lacks a true theory of mind. It doesn't possess self-awareness or understand your emotions. It just retrieves relevant data very effectively. So how does a limited memory system learn to make those decisions without a programmer typing out every single step? That brings us to the third layer, training. This graphic illustrates the shift. On the left, traditional software follows rigid, explicit rules. On the right is machine learning. Here, the system digests large amounts of data and begins finding patterns and relationships on its own. The most advanced form of this is deep learning. It relies on layered neural networks to process complex inputs, like human speech or detailed imagery, breaking them down layer by layer. Despite the biological-sounding name, deep learning is purely mathematical. Its success relies entirely on the quality of its data diet. It is an engine for recognizing patterns, completely devoid of cognitive comprehension. The final layer of the stack is application. This is where the underlying math becomes the tangible tool sitting on your desk or in your pocket. Applications are defined by their output. Generative AI creates text or images. Predictive AI forecasts future trends. Conversational AI talks to users. And computer vision acts as the eyes, interpreting pixels from a camera. This raises a crucial question. How can a single software program simultaneously exist as multiple different types of AI? Let's look at a practical example. Imagine a small e-commerce company gets overwhelmed with support emails, so they deploy an AI triage assistant to process customer complaints, like one about a damaged table. To handle this single email, the assistant uses conversational AI to read the text. It uses predictive AI to calculate the probability that the customer will demand a refund. Finally, it uses generative AI to draft a polite reply based on company policy. Those 3 applications are simultaneously powered by deep learning on the training layer, functioning as limited memory on the functionality layer, all safely confined within the boundaries of a narrow AI capability. The triage bot generates its output through a mechanical execution of data layers, operating without any internal awareness of the customer's frustration or the physical reality of the furniture. Because these overlapping layers interact so seamlessly, they project a powerful illusion of fluency. They trick us into believing the machine actually understands the context of the work it's doing. Every hidden layer introduces its own specific risks. Generative layers can confidently invent false facts. Predictive layers will mathematically reinforce historical biases found in their training data. Vision layers can easily misidentify objects. Your strongest defense against these mechanical errors is transparency. You have to interrogate the tools you use, asking what data shaped them, how their logic operates, and where their strict limits lie. This requires a shift from being a passive user to an active operator. AI is a tool, and like any high-powered tool, it demands clear boundaries, routine testing, and constant human oversight. True AI literacy requires recognizing the architecture of these systems, mitigating their specific risks, and ensuring that human judgment remains the final word in every automated decision.